Okay, now we're working on page 5 of the core exam. First it says, use synthetic substitution to find f of 2 if f of x equals this. What this notation f of 2 means, it says, hey, x equals 2, I want you to put it inside f. So it's kind of like, oh, I'm going to put 2 here, 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 I'm going to put 2 here. And then after I substitute them in, I'm going to take it to the fifth root, the fourth root, or I'm taking it to the fifth power, the fourth power, the third power, and then after you do all this multiplication, you get some number. But remember, there's a really easy way to do this called synthetic substitution. You don't need to take powers. You don't need to do a lot of complicated multiplication. You only need to do very basic multiplication and addition, so it's easy to do. First thing you're going to do is you're going to say, okay, I want to substitute the value in for 2, so I'm going to write 2 here. Next, I'm going to take all the coefficients for this function, and remember that the minus signs are part of the coefficient. And I'm going to write the coefficients here. I'm going to put -2, 3, 5, -11, and -1. And then, so I don't need this space over here. Oh, yeah, I do. Look. There's a missing term. There's no x term. So that means I do need this space. So this is the x to the fifth term. This is the fourth term, third term, second term. X to the first term doesn't exist, so I'm going to put a 0. And then the x to the 0th term, which is the constant term, is -1. Okay. Now I'm going to start the synthetic substitution process. And if it's hard to remember, go ahead and write on your note sheet how do you actually do it, or put in an example. Okay? The way you do it is first you bring down the first number, -2. Then you multiply it times this number that's over here, -4. Then I add them together and I get -1. Then I multiply -1 times 2 and I get -2. I add them together, the 5 and the -2, and I get 3. Then I multiply times 2 again and I get 6. And then I add them together, I get -5. And you can see that this is not a complicated process. In fact, it's quite easy. Kind of addicting, but it's easy. And it turns out that the value for y that you get when you put x into this function is -21. Isn't that easy? All you did was really easy multiplications without a calculator, and really easy addition and subtractions also without a calculator. So, synthetic substitution is a way to impress your friends and family. All right, and it turns out that synthetic substitution can do something that is very, very difficult, that cannot be done, just by doing a few powers or whatever. So it's definitely worth learning. So let's say I have quite a complicated division to do. I have this expression divided by this expression. That's quite a complicated division. It turns out that I can do it in a similar way. I take the coefficients of this polynomial, which is in the numerator. And remember, there's no x term here, so it would be 0x. So I'm going to put -2, 3, 5, -11, 0, and -1 for the coefficients. Then I'm going to take the root for this binomial. The root for the binomial is 2, because that's the value, if I put in there, would make the thing 0. 2 minus 2 is 0, right? So then I start my synthetic substitution work, but this time it's called synthetic division. And the result is -21, just like before, okay? But now I'm going to interpret it differently. Remember that originally this was x to the fifth, this was x to the fourth, and so on, right? When you do the division, the bottom row has different meanings. The x to the fifth, below the x to the fifth term, now we have the x to the fourth term. So all these terms are like, they descend 1. And like this will be what we call the remainder term. And let me show you how you write it out. So like it's going to be -2x to the fourth, -1x to the third, plus 3x squared minus 5x and minus 10, and x to the 0 is just 1, so I don't need to write it. And then I write minus 21 divided by the denominator, which is x minus 2. And that's how I write the remainder. Okay? Page 6. Graph the parent function and the transform function of f of x. And remember, this is the exponential function with the base of 3. Okay? And if we would like to draw the parent function, one of the easiest ways, I think, to do that is to make a little table and then put some values in for x. And then you say, okay, the parent function for this is y equals 3 to the x. So I'm going to plug numbers in, 0, 1, and 2, in for x to see what I get. Well, 3 to the 0 is 1, 3 to the 1 is 3, and 3 to the 2 is 9. Okay, so these are three values I could use in my graph for graphing the parent function. So this is just the parent function. It's not the transformed function. Let's draw the transformed function in red. Okay, you can see that the difference between the parent function and the transformed function is the transformed function has this negative 2 here, and it's got a positive 1 here. Okay, remember that the value that is being subtracted from the x is like the h value, okay, which is like a horizontal transformation. And the value that is being added at the end is like the k value, and the k value is like a vertical translation. Okay, so basically what we got here is horizontal translation positive 2, and it's positive 2 because it's minus h, okay, and the vertical translation is positive 1. So this is to the right and this is up. Write the equation of the asymptotes, draw the asymptote with a dotted line on the graph. Okay, if you remember, the asymptote of the exponential function is the k value here. Okay, because normally when you have an exponential function, the parent function, the asymptote is y equals 0. Okay, and then whenever you translate it vertically, then you're going to add the k value to that. So the equation of the asymptote instead of y equals 0 is going to be y equals 0 plus 1, which is y equals 1. Okay, so that is the equation of the asymptote. Draw the asymptote with a dotted line on the graph. So the y equals 1 line is going to be here. Oh, wait a second. I didn't even draw the parent function yet. So let me draw the parent function first because I want to graph the parent function. The 3 points I'm going to graph on the parent function are 0, 1, 1, 3, and 2, 9. 0, 1, 1, 3, and 2, 9. That's the parent function. And the parent function asymptote is y equals 0, so that's why it gets close to y equals 0. Now I'm going to do the transformed function. The transformed function is the parent function, but it undergoes a translation, 2 to the right and 1 up. So let's take each one of these points and go 2 to the right and 1 up. 2 to the right and 1 up. 2 to the right and 1 up. Now I'm going to draw my transformed function. Notice the transformed function approaches the asymptote y equals 1, which is the dotted line here. Okay? So, and then finally it says write down the domain and range of the function. The domain, you can see that all x values are valid, right? So the domain would be x is all real numbers. And then the range, you can see that only like certain positive numbers are valid. And for the red function, you can see that those values start at y equals 1, right? Now, would it include the value y equals 1 exactly? No, because look at the dotted line asymptote. It does not include y equals 1. So the range is going to be y is greater than 1. Okay? And that was page 6. So that's the end of this video.